Good afternoon. Thank you for the opportunity for all the students here. Today, I'm going to present my final project at Data Science Bootcamp at the Bimbing. My project is Airline Customer Satisfaction Analysis by me, Muhammad Haikal Akyat. The background of this project is in today's competitive aviation industry, customer satisfaction play a role in shaping an airline's reputation and profitability. Leveraging the power of data, this project aimed to predict airline customer satisfaction by analyzing key feature, what feature importance and what impact most to the customer satisfaction. By empowering advanced machine learning technique, this project seeks to provide actionable insight that provide airlines to enhance their services, foster customer loyalty. The objective of this project is using a classification model to forecast customer loyalty and determine the primary determinant of airline customer satisfaction. For this analysis, I'm using an Ensemble model, random forest, extreme gradient boosting, and light gradient boosting. The goal of this project is to improve the overall customer experience while also providing business recommendation to optimize the airline's company. Today, I'm having a seven section of this presentation. First, EDA, exploratory data analysis, and then we're going to data preprocessing, data modeling, explanation AI to explain the black box model because I'm using ensemble model which is cannot be directly implement directly interpreted. Next, I'm going to analyze and giving recommendation, and after that, I deploy the model using uh, Streamlit. This is the dataset overview. I get the data from kaggle.com. You can access the data on right below on the screen. The dataset is contained 23 columns with one 100,000 over 100,000 rows. For this analysis, I'm going to predict the satisfaction of the customer, whether they're satisfied or not satisfied. First, we're going for the exploratory data analysis. This is the numerical column statistics. As we can see that most of the categorical columns are ordinal column from range 0 to 5 because this is the dataset which is based on the feedback from the customer from range 0 to 5 for their services like in-flight Wi-Fi service, departure time convenient, ease of online booking until cleanliness is all the rating given by the customer. Unnamed 0 and ID column can be dropped because this column doesn't have any significant value to the data. So I'm deciding here for this analysis going to drop these two columns. And there's a column with potential outliers in departure delay in minutes, arrival delay in minutes, and flight distance column. They shown the categorical column statistics. The unique counts for categorical feature have less than 4 unique value, which is fine. As we can see that most of the customers from business class, business travel, and most of the loyal customer and most of the customers are female. And data is quite unbalanced here because as we can see that the satisfaction class most of the customer are neutral or dissatisfied for the airline's customer services. This is dataset summary. Among the 22 columns, there's one column with missing value in arrival delay in minutes column with 310 missing value data point. It's about 0.29% missing value. for further analysis, we're going to fill this missing value with median or mean. Summary of the data. This dataset contain 5 categorical columns, 18 numerical columns with 18 numerical columns, and there's missing value on arrival delay in minutes with 310 missing value, and we got no duplicated row here. This is the customer satisfaction proportion between class neutral or dissatisfied and class satisfied. As we can see that the data is quite not balanced. 57% for neutral or dissatisfied class and 43% for satisfied class. Neutral or dissatisfied, it's on the same level. Neutral or dissatisfied, which is neutral and dissatisfied are on the same level, so I decide to use the dissatisfied or not satisfied. We're going to change the class neutral or dissatisfied to not satisfied later on data preprocessing. Distribution plot for all the numerical columns. Departure delay in minutes and arrival delay in minutes both has many outliers, as we can see at the right bottom. Using a box plot, departure delay in minutes and arrival delay in minutes has many outliers with a right skewed distribution. Most of the numerical columns are categorical ordinal columns, which is form a level between level 0 to 5. Edge distribution is quite close to normal distribution, which is normal. Next is customer satisfaction by class. We want to analyze, is class chosen by the customer affect the customer satisfaction? And after I'm plotting, we're using the box plot, we can see that the business class, the customer using a business class is much more likely to satisfy to the airlines services, and Eco Plus here is the minority class. So class is one of the high predictor for customer satisfaction. Next, we're going to see gender. Is gender affect the customer satisfaction? In this plot, the gender is not really have any influence on customer satisfaction because both gender, male and female, almost have the same data distribution. Now we want to see the customer type. Is customer type affect the customer satisfaction? There's two classes on customer type: loyal customer and disloyal customer. And loyal customer will likely satisfied for the airline services, while disloyal customer not. And most of the flight customer are from loyal customer, and because of this, the height differences between class loyal customer and disloyal customer type is one of the high predictor candidate for this analysis to predict the customer satisfaction. Next, we want to see the type of travel, which is whether the type of travel will affect the customer satisfaction. There's two classes on the type of travel: business travel and personal travel. And most of the personal travel here are not satisfied with the flight services, while the business travel will likely satisfied to the airlines services. This makes sense because that personal customer use their own funds to travel, while business travel use their company funds. The personal travel customer have higher expectation for the flight services. So because of this, type of travel is one of the high predictor candidate to predict the customer satisfaction. This is the count plot for ordinal category. The rating given by the customer from rating 0 to 5 we see that every increase of the level, it's supposed to be the satisfaction will increase. The customer who's satisfied will increase. And I conclude that the in-flight Wi-Fi service, ease of online booking, seat comfort, in-flight entertainment, onboard service, baggage handling, and in-flight services are the high priority candidate for customer satisfaction. We see that every increase, the column that I've mentioned before, that every increase, 1 point increase on the feature, it will increase the count, the number of the customer who's satisfied. Next, we're going to see the correlation between feature using heat map correlation matrix. Departure delay in minutes and arrival delay in minutes are highly correlated because it makes sense because the customer who depart delay will must be arrive delay private delay. And next, data preprocessing. Since we don't have the duplicated row, we do nothing for the duplicated row. For missing value, 300 missing value on arrival delay in minutes, we will fill the missing value with median because so many outlier on arrival delay in minutes column. So I'm using median here, not using mean or average. Feature engineering, we're dropping the redundant feature. When I try to calculate the fifth score for the column, arrival delay in minutes and departure delay in minutes is highly correlated with 13.5 FF score, and I decided to drop one of the column. For this analysis, I dropped the arrival delay in minutes. So after I drop the arrival delay in minutes, the fifth score is quite good with less than 3.7 or less than 4, which is fine. Next, feature engineering. Encode the object column with label encoder. The categorical column here is gender, customer type, class, and type of travel, as we seen on the table. And after I encode the categorical column, I standardize the data. The purpose of standardize our data is to ensure that all features are scaled appropriately, especially for our algorithm which are sensitive to scale difference in feature. This is mostly the algorithm with a distance based like KNN, SVM, K-means. If we are using the tree based model like decision tree, random forest, or XGBoost gradient boosting, white gradient boosting, or any other tree family, it's not necessary to standardize our data. For this analysis, I'm still using the standardized data because I'm using the weak model as a baseline. Next, the third section, modeling and evaluation. I'm using the model logistic regression for baseline model and a tree family ensemble model, random forest classifier, XGBoost classifier, and light gradient boosting machine classifier. This is the result of our baseline model here. Logistic regression performs well with F1 score 83%. Why I'm using the F1 score as a matrix? Because the data is quite unbalanced here, so using F1 score is more logical than using the accuracy. If your data is balanced, you can use accuracy here. For my analysis here, I'm using F1 score. This is the conversion metric and classification report for logistic regression. Next, I'm using the first tree family model random forest classifier. Random forest classifier performed very well with 97% F1 score. Before I implement the model, I'm using random grid search to find the best parameter for random forest. This is the classification report, confusion matrix, and feature importance for the random forest classifier. As we can see that online onboarding and in-flight Wi-Fi service has a high impact on the customer satisfaction based on random forest classifier. Next, the second tree family I'm using is extreme gradient boost classifier. Extreme gradient boost classifier is performed nearly the same with the random forest classifier with 97% F1 score. Before I implement the model, the same with the random forest, I'm using the random grid search to find the best parameter for extreme gradient boost. This is the classification report, conversion metrics, and feature importance for the extreme gradient boosting classifier. It's different from the random forest. For in the feature importance section, online boarding and type of travel has a high impact on the customer satisfaction based on XGBoost classifier, while random forest classifier, online boarding and in-flight Wi-Fi service has a high impact on the customer satisfaction. Almost 40% that online onboarding affect the customer satisfaction. Next family tree we're gonna use is I'm using here is light gradient boosting machine classifier. Light gradient boosting machine here has nearly the same as the extreme gradient boosting and random forest classifier with MFOS score 97%, and same as previous Ensemble model. I'm using a random grid search to find the best parameter for light gradient boosting, seen as this screen right now. And this is the classification report, conversion metrics, and feature importance for light gradient boosting machine. In light gradient boosting machine, in-flight Wi-Fi service and age has a significant effect on the customer satisfaction. Next, model summary using AUC or area under curve. This AUC determine the true positive rate or model performance. True positive rate, true positive, and true negative. The tree family model, random forest, XGBoost, and light gradient boosting machine has AOC score 0.99 or 99% correctly predict the customer satisfaction, while logistic regression AOC with 90% AOC. Well, this is logic because the logistic regression model is not better than random forest and XGBoost and light GBM because this is the moderate model is not weak or is not strong enough, as shown out as the ROC curve above. This is typical because since complex data set here are not a good fit for logistic regression, but I'm still using it as a baseline model. We are employing logistic regression. This is the summary of model performance. Light gradient boosting performed better compared to other model implement here. So in this analysis, I'm going to use light gradient. I decide to use the light gradient boosting machine model because it has a better metric score compared to other model. Explanation II to explain the model. The first Next I'm gonna use is promotable feature importance. In-flight Wi-Fi service and type of travel has a high impact on customer satisfaction based on random forest classifier. While like gradient boosting classifier, it's same in-flight Wi-Fi services and type of travel. XGBoost also the same in-flight of Wi-Fi service and type of travel, which is in-flight Wi-Fi service and type of travel has a significant effect on the customer satisfaction based on three model Ensemble model that I'm using here. But I have to decide which model I'm going to use for this case. As we can see that using a line, we can see the rule of each model, which is more reasonable. From my point of view, in my opinion, that like gradient boosting classifier is more reasonable compared to random forest and XGBoost classifier, because the direction of the type of travel and customer type, which is more high significant effect on the customer satisfaction with 50% effect on type of travel column, 50% type of travel feature impact the customer satisfaction, while customer type affect 37% to the customer satisfaction, and the direction, satisfied or not satisfied. Well, in the random forest classifier, the direction is not clearly reasonable because it's quite wrong if I choose. And for this analysis, I'm going to use light gradient boosting machine classifier. It's more reasonable compared to those three ensemble model. Analysis and recommendation. This is a model review that I jelaskan sebelumnya. XAI interpretation using promotable feature, using partial dependence, and using Lime. Recommendation given to the airlines services. First, giving the customer satisfaction by type and loyal enhancement strategy. Loyal customers have a high chance of being satisfied, while disloyal customers tend to be dissatisfied. My recommendation: giving a loyalty program, increase effort to retain loyal customer through loyalty program, such as special offer, priority access, or exclusive discount. Second, giving a new customer retention, identifying the disloyal customer and implement better onboarding program, such as first trip offer. Next, second, focus on business travel customer. Business travel customer tend to be more satisfied than personal travel customer. My recommendation is premium services. Improve premium services for business customer, such as a lounge facilities, quick rescheduling services, or a high-speed access on board or even at the lounge. The second recommendation: personalization for personal traveler. Identifying the unique needs of personal travel customer to enhance their experience, such as with addition entertainment, destination promotion, or family packages for personal traveler. The three key service improvement based on aspect affecting the satisfaction. Low rating on aspects such as in-flight Wi-Fi services, online onboarding, legroom, cleanliness, baggage handling, in-flight service, and gate location contribute greatly to unsatisfied customer. Recommendation on Wi-Fi services: improve the speed and stability of the in-flight Wi-Fi service by investigating in technology infrastructure. Second, Online onboarding. Optimize the online onboarding experience, for example, using user-friendly application UI UX and clearly integration of flight information, whether they give a delay or on time. Third, legroom. Add a seat option with more legroom for customer in competitive price. Next, cleanliness. Improve aircraft or waiting room cleanliness with more frequent inspection, and give some schedule to the baggage handling. Reduce complaints related to baggage handling by speeding up the process and improving communication of baggage status through the app that I mentioned before on online onboarding, giving a user-friendly application UI UX. And next, last, positive feedback improvement program. Customer give low rating for various services if they are unsatisfied. My recommendation, a post-flight survey. Improve the process of collecting post-flight feedback with a reward point for participation, reward point for the next flight, or they can use it for other flights as long as it's on the same year, or they are giving a point with uh, uh, expiration expire date. Hmm. Giving a quick wins. Focus on improving area that receive low rating in previous survey to make an immediate impact on customer satisfaction. And that's all the recommendation I can give to the airline services. Next, I'm using a Streamlit to deploy my model. This is the simple application that I built on the Streamlit. You can input the feature on the app and predict the result. Like you input your gender, customer type, age, type of business, class, flight distance, and the rating on such services and predict. And for this customer, he or she is not satisfied for the airline's services. This application makes prediction by using the Streamlit app with NG-Rock tunnel. And this app can be accessed at the following link. That's all for my presentation. I hope you'll get insight from what I present. Thank you for your attention, and I'll be welcome if there are any question on my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi